Video 11 Solar Electric System Options. The PV systems fall into three categories: grid connected systems with battery backup, off-grid systems. In this video we'll examine each system and those that couple PV electric systems with other renewable energy sources. The information in this video will help you decide which system suits your need and lifestyle. A grid-connected PV system. A grid-connected PV system are the most popular solar electric systems on the market today. The grid-connected systems are also named because they are connected directly to the electrical grid. The vast network of electric wires that spans the nation and crisscrosses your neighborhood. These systems are also sometimes referred to as batteryless grid-connected systems or batteryless utility-tied systems. A grid-connected system consists of five main components: a PV array, an inverter, the main service panel or breaker box, safety disconnects, and meters. To understand how a batteryless grid-connected system works, let's begin with the PV array. The PV array produces DC electricity. It flows through the wires to the inverter, which converts the DC electricity to AC electricity. AC versus DC electricity. Electricity comes in two basic forms: direct current and alternating current. Direct current electricity consists of electrons that flow only in one direction through an electrical circuit. It's the kind of electricity produced by a flashlight battery or the batteries in portable devices like cell phones and laptop computers. It is also the kind of electricity produced by photovoltaic modules. Most other sources of electricity, including wind turbines and conventional power plants, produce alternating current electricity. Like DC electricity, AC electricity consists of the flow of electrons through a circuit. However, in an alternating current, the electrons flow back and forth. That is, they change direction in a very rapid succession, hence the name. Each change in direction of flow is called a cycle. In North America, electrical utilities produce electricity that cycles back and forth 60 times per second. It's referred to as 60 cycles per second or 60 Hz AC. In Europe and Asia, the utilities produce 50 cycles per second. Inverter. The inverter doesn't just convert the DC electricity to AC. It converts it to grid compatible AC, that is 60 cycles per second, 120 volt or 240 volt electricity. Because the inverter produces electricity in sync with the grid, inverters in these systems are often referred to as synchronous inverters. The 120 volt or 240 volt AC produced by the inverter flows to the main service panel, aka the breaker box. From there it flows to active loads, that is, to electrical devices that are operating. If the PV system is producing more electricity than is needed to meet these needs, which is often the case on sunny days, the excess automatically flows onto the grid. Frequency and voltage. Alternating current is characterized by two parameters: frequency and voltage. Frequency refers to the number of times electrons change direction every second and is measured as cycles per second. The flow of electrons through an electrical wire is created by force. The scientists refer this force to as voltage. The unit of measurement for voltage is volts. Voltage is more difficult term to understand. You can think of it as electrical pressure, the driving force that causes electrons to move through a conductor such as a wire. Without it, electrons will not move through a wire. Voltage is produced by batteries in flashlights, solar electric modules, wind generators, and power plants. The surplus electricity travels from the main service panel through the utility's electric meter, typically mounted on the outside of the house. It then flows through the wires that connect to the utility lines. From here, it travels along the power lines running by a home or business, where it is consumed in neighboring homes and businesses. Once the electricity is fed onto the grid, the utility treats it as if it were theirs. End users pay the utility directly for the electricity you generate. In addition to the utility electric meters or meters, some utilities require 2 or more meters. 2 meters that monitor the flow of electricity to and from the local utility grid. Grid-connected solar electric systems also contain 2 safety disconnects. Safety disconnects are manually operated switches that enable the service personnel to disconnect key points in the system to prevent electrical shock when servicing the system. The first disconnect is between the solar array and the inverter. This is a DC disconnect. The manual disconnect allows the operator to terminate the flow of DC electricity from the array to the inverter in case the inverter needs to be serviced. These systems also require an AC disconnect switch. This disconnect must be mounted outside the home or business. It must be readily accessible to utility workers and must contain a switch that can be locked in the open position by utility workers so no electricity flows to or from the grid. This disconnect is required so workers can isolate PV systems from the electrical grid and work on electrical lines without the fear of shock, if any. Here ends video 11, Solar Electric System Options.